Okay, this is May 2008, question 1. So, part 1, we have a mass of 100 kilograms being raised by a wire, and we're told that the tension in the wire is 1,000 newtons, and we're asked to calculate the acceleration of this object upwards. Alright, so we can label all our forces on the diagram in the direction of motion. So we have 1,000 newtons upwards, and we have the weight downwards, which is 100 G. If we use F equals ma, where F is the resultant force upwards, then we have 1,000 minus 100 G. Notice we start with the 1,000 because it's acting upwards, the object's moving upwards, and that's the upwards force. So F equals ma. And if we solve that, we get the answer A is 0.2. That's part 1. Part 2 gives us the situation where the same mass is being pulled upwards by a force T, and it produces an acceleration of 0.8. So this time we're not being asked to calculate the acceleration, we're given the acceleration and we're being asked to calculate T. So we still have the weight downwards of 100 G. And so if we use F equals ma, well, we have F is T minus 100 G, and that equals m, which is 100, times a, which is 0.8. And if we solve this, we get T is 1,060 newtons. Okay, part 3. Part 3 places the mass inside a tube, still being raised upwards by a wire, but this time the wire is at an angle of 30 degrees to the vertical. So we'll call that T, and we can still put on the mass of 100 G, and we're told that it's pulled up again with an acceleration of 0.8 meters per second, and we're asked to calculate T. Okay, so we're still going to apply F equals ma, and F is still going to be the resultant force in that direction, because that's the direction in which the object moves. So that's the direction for which we need to calculate the resultant force. Now, upwards, we have a component of the tension acting in that direction, and it's T cos 30. The 30 connects the T with the direction we're interested in, and cos connects, so it's T cos 30. So upwards, we have T cos 30 minus the downwards force, which is 100 G, and that equals m, which is 100, times a, which is 0.8. So F equals ma. If we now substitute G as 9.8 and we rearrange this, we get the answer that T is equal to 1,223.98, but it asks for 3 significant figures, so that gives us 1220 newtons to 3 significant figures. And that's the end of question 1.